First chapter, a real number. In real number, the first theorem is fundamental theorem of arithmetic. Every composite number can be uniquely expressed as a product of primes except for the order in which this prime factor occurs. It means it says that any numbers, let's take the example 20. 20 can be written as a product of all the prime number. So first find the prime factor of 20. Means we have to take the number the prime which divide 20. First divided by 2, it gives 10. Again divided by 2, 5. So here how many prime numbers are there? There we got 20 equal to 2 into 2 into 5, or 2, that is repetition 2 twice, that is 2 twice, it will be written as a prime power into 5. So how many prime number? There are 2 prime number. It states that the theorem states that every composite number means first you have to know what is the prime number and what is a composite number. Prime numbers, the number which is divisible by 1 and itself. Example 3, 2, 5, 7. It has only 2 factor, 1 divisible by 1 and by itself. This is same, divisible by 1 and by itself. This is also same, 7, it's divisible by 1 and divisible by 7. So these are the prime number. There are lots of prime numbers are there. And what is the composite number? Composite number means the number which has more than 2 factor. The first composite number, that is 4. So let's take the factor of 4, means by what number the 4 is divisible. So first it's divisible by, it's clearly divisible by 1, because if we divide 4 by 1 we will get the result 4, and it's divisible by 2 because 4 can be divided by 2, and again 4 is divisible by 4. So how many factor? 1, 2, 3. So it is a composite number. Composite number. So it says every composite number. So it's every composite numbers can be uniquely expressed as the product of prime number. So this is the product of prime number. Again this 4 can be written as 2 into 2 because 2 is a prime. So here what are the prime number? 2, this also 2. So we got the prime number. Product of primes means 2 into 2, we got 4. So 4 can be written as 2 into 2. So it says that product of prime. Product means multiplication of prime. Any composite number can be written as a product of a prime number. That is a simplest statement. So this is the fundamental theorem of arithmetic. It states any number means any composite number. So what is the first composite number? The first composite number, there is a 4. This is the first composite number. The first prime number, there is a 2. So now we need the numbers. What is the number? First we come to know what is the prime number. The number which is divisible by 1 and itself. This is the prime number. Example 2, 3, 5, 7, 11, 13, 17. It's go up to infinity. Then composite number. Composite number. Composite number 4, 6, 8. Then comes the natural number. What is a natural number? The number which is countable. Natural number is represented by capital N. Number which we start counting, that is 1. We always start the counting from the positive number, not by a negative number. So 1, 2, 3, 4, it will go up to infinity. And whole number. Whole number. That is we represent by capital W, where in the natural number if we add the 0, that becomes the whole number. So 0, 1, 2, 3, 4 it will go up to infinity. After this it comes the integer. Integers, it's represented by either it will represent by z or it will represent by capital I. What are the integers? That will come from the minus infinity. It will start from the minus infinity of the minus 1, minus 2, minus 1, 0, 1, 2 up to infinity. It can be written as, always we represent the set inside the curly bracket. It can be written as 0 plus minus 1 plus minus 2 plus minus 3 up to infinity. It's both are equivalent. The meaning are same. So integer, and it's after that it will call the rational number. What are the rational number? Rational number. Rational number, it is the number that are written in a fractional form, that is p divided by q, and q does not equal to 0. Q does not equal to 0. Example 2 by 3. This is also rational number. 1 also rational number. 2 also rational number, because 2 can be written as 2 by 1. So all these are rational number. And rational numbers, in the rational numbers it can be two terms will come. One is terminating numbers, another is non-terminating numbers. Now what is the terminating? It's the part of a rational number. Terminating numbers are the numbers which means after the division there is a means no repetition of a number. It ends after the dividing. If a number is divided by any numbers, it's come to a there is no means no remainder. If the remainder is 0, that is a terminating. Example, that is 0.12 or it can be 0.1, means after the division there is a remainder. There is no remainder, so it's a terminating. And non-terminating number, so it will repeat, that is 0.3333, 0.141414. This is a non-terminating numbers. After that it will be a irrational number. Irrational number, the number which neither terminating nor non-terminating, means after a division there is no remainder, but the number will not repeat. Example 0.1234, it will go, or we can write a root 2, value of root 2, value of root 3, value of root 5, because after finding the value of root 2 it will goes after the infinity, but there is no repetition of the number. So it is a irrational number. These are the number we required in this chapter. So now again we need the LCM and the HCF. So what is the LCM and what is the HCF of a number? So HCF, highest common factor, that is product of the smallest power of each common prime factor in the number. And LCM means we will check the all the first for finding the HCF. First we have to go for the, at least we need two numbers, that is two composite number. From the two composite number we will do the first prime factorization of two numbers separately. After that we'll compare the, we'll take the highest, means product of the smallest power of the each, means first we will check the how many prime numbers are there. From that prime number we will check the smallest power, means smallest prime number have to be taken. And LCM is the, here you have to take the greatest number, product of the greatest power of each prime factor involved in the number, First there will be two number. From two number, first prime factorization has to be done. After finding the prime factorization, the prime number have to be checked from the prime number. So from the prime number, the highest power will be taken. So that will be the LCM. In the LCM, highest power of a prime number, and in the HCF, smallest power of a prime number. So let's do the example. So let us take the two number, that is any number 16 let's take 16 and 20. First, what we have to do? First, we have to do the prime factorization. Prime factorization means finding all the prime number which divide 16, means all the prime number. So first, 16 is divisible by which prime? It's divisible by 2. How I know this is divisible by 2? Because in the end, in the last digit, if it is 0, means even number, that is 0, 2, 4, 6, 8. Then in the last digit, it's 0, 2, 4, 6, 8. Then this number is divisible by 2. So this is divisible by 2 divided by 2. So it will give 8. Again 8 is divisible by 2. 4 2 is 8. Again 4 is divisible by 2. 2 2. Now come to the 20. First, it's divisible by 2 and it's also divisible by 5. First, you can go by any of the number, either 2 or by the 5. So you will get by the 2, 10, again divisible by 2, 5. So now arrange it. That is 16 is equal to 2 into how many 2? 1, 2, 3, 4. 1, 2, 3, 4. You can keep it here also, or you can rewrite as 2. How many 2 are there? 1, 2, 3, 4. This also can be written. Both are equivalent, means similar. Now 20 can be written as 2 into 5. That is how many 2? 2 are repeated twice, 1, 2 into 5. Now we are going to find the LCM and the HCF. First, let's find the HCF. HCF means the common number which belongs to both the number. So here is a 16, here 16, here 20. Just take the compare the common number. It's simplest way. So common number, that the prime number have to be both in 16 and 20. So here we have 2 and here also we have 2, and again here we have 2, here we have 2. There is no more any common. So here 2, so read 2, this 2 and this 2. So this is 5 4. So this is the HCF. Now come to the LCM. So LCM means highest power. First, write all the prime number. How many prime numbers are there? 2, all are 2, and 5. So 2 and 5. Now check the highest power. 2. Here 2 power is 4. Here 2 power is 2. Here 2 power is 4. 2 power is 2. Which one is the highest? 4 is the highest. So it will be 2 to the power 4. Now 2 to the power 4 means 2 will be written as 4 times. 2 into 2 into 5. So it will give, first whenever you see the 5 and the 2, if you multiply 5 and 2, it always give the 10. So always multiply this first. So it will give 5 to the 10. Now multiply the remaining. 2 to the 4, 4 to the 8. So it gives the 80. So either in another way also we can do, that is HCF. HCF, what does it say? HCF is the smallest power. The smallest power. First check the prime number which we have in both. So here 2, here 2, 5, here we have, here we doesn't have the 5. So which one you are going to take? You are going to take only the 2. So you got 2. and C. Both are similar. So 2. Now check which one is the smallest power. Here 4. Here 2. Which one is the smallest? 2 is the smallest. So take the 2 power 2. If you take the multiply, 2 into 2, that is equal to 4. This is also correct. Now the relation between the LCM and the HCF. The relation of HCF and LCM. So there is a relation of the LCM and HCF. See, while finding the HCF and LCM, we need a 2 number. So let that 2 number be A and B. So A into B is equal to HCF of A comma B into LCM of A comma B. This is the one. Another is, this is the one. Another means LCM is completely divisible by HCF. That is, HCF divides LCM completely. Means, what do you mean by completely? Completely means if you divide a number by another number, there is no remainder. Okay, let's check it out. So we come to know that product of the 2 number means which 2 number we find the LCM and the HCF. If we multiply that 2 number, that result will also equal with the HCF and the HCF into LCM of that number. So we already taken the example, that is 16 and the 20. So I'm going to complete with this example only. So we have taken the 16 and the 20 and we got the HCF how much? We got the HCF 4 and we got the LCM 80. So now let's prove the first one, that is product of the 2 number. So 16 and 20. We have the number 16 and 16 into 20. So multiply the 16th and 20. So 16th into 20. Multiply it. So it will give, that is 16, 0, 2, 3, 2, 0. This is the product of the 2 number. And what is the HCF we got? HCF we got 4. LCM we got 80. So multiply it. That is 32. So it gives the equal. This is the A into B. This is HCF of A comma B into HCF LCM of A comma B. So this always it have to be equal. So product of 2 number is equal to the product of, multiplication means the product of HCF of that number and the LCM of that 2 numbers. Now the second, what does second statement says? HCF divides the LCM completely, means HCF divides the LCM completely. What is the LCM we got? LCM we got 80. That is the LCM divided by HCF. LCM we got 80. LCM we got 80. HCF how much? HCF that is 4. Divide it. It's divisible by 4. 4 2 is 8. So it gives the 20. So there is no remainder. So it divides completely. So these are the relation. What is the relation? Product of 2 number is equal to product of LCM and the HCF. Second, HCF divides the LCM completely.